Welcome, this is the MATLAB and Simulink Racing Lounge. In today's session we will talk about versioning of your Simulink projects with Git. And today's expert who will introduce us to this interesting topic is Joachim Schlosser. Joachim?
Hi.
Hey, so what is versioning and what is Git?
So versioning, well, suppose you have done your model, you have implemented something in a MATLAB script and you have created a beautiful Simulink model, and now you've made a change, and now the next day you recognize, oh, that was wrong, that I messed up my model. What do you do?
I usually I go back to a state that I've hopefully saved.
Yes, you go back to a state that you've hopefully saved, but where did you save that state? Well, people either save in multiple file names, they apply a suffix version 1, version 2 and so on, or you better use a versioning system.
Okay.
A versioning system does exactly that for you,
Mm-hmm.
and I hope that a lot of the teams out there are using a versioning system, like for example Subversion or, as said, Git. And Git is such a versioning system. It's an open source versioning system, very popular also in the Linux community.
Mm-hmm.
So the kernel developers are using that.
Okay.
And it's become increasingly popular in the academic community in the last couple of years.
Okay, got it. So it's extremely helpful also when
Oh,
cooperating in a team.
Oh yes, absolutely. So whenever you're working in a team size bigger than, I say, 1, so 2 people or more, you absolutely need to use a version.
Okay. And what about the support of MathWorks and Git?
So beginning of, I think, the last release, there is Git support in Simulink.
Okay.
In Simulink Projects, and that is what we're going to talk about today.
Great. Cool.
So since you were asking about Git, maybe we should take a look on what Git is, how to learn more about Git for the people who haven't seen Git before, and also what to download and how to install that.
Please. I haven't used it either. So.
Okay, so let's jump over to the Git web page that lives on git-scm.com. And when you start there, I recommend that you first take a look at the About page, which gives the 2 most important terms for Git right here. And this is what is painful in other versioning tools. Branching and merging is kind of the basic concept in Git. You constantly are branching and merging things, which makes it very easy for you to try out stuff. If you want to learn how to use Git, then I recommend you go to the documentation section on their webpage and start with the 4 introductory videos. By the length, you see it roughly is 4 to 8 minutes per video. So after about 20 minutes, you're already not really proficient, but you know how to deal with the very basic Git concepts. After you've watched the videos, I recommend that you download this thing, either for Mac, Windows, Linux, whatsoever.
Okay.
And when you install it, now very important, at a certain point in time it asks you whether you want to use the Git commands from the command line.
Okay, command line.
Please say yes.
Okay.
Because while Simulink comes with its own Git client, for some rare occasions, for example in merging, it needs the functionality that comes with the command line client.
Okay,
so
perfect.
Be sure to install that. And I'd say let's just
let's start.
Let's move over. So the question is, how do you get to the concept of a project? So what is a project for you?
Well, a project are tasks that belong together and have the same goal, have to be done in
tasks and in terms of a model, it's kind of artifacts.
Yep.
It's artifacts that are bundled together.
Right.
And so in Simulink there is a tool called Simulink Project that does exactly that. But before that, let me quickly explain the example model that we're going to try out here. I brought with me the double wishbone model, and I think I saw this already.
Yeah, we have brought that model in CAD import in a previous session of the Racing Lounge.
I see. So let's quickly start that model, and just to show a little bit what's going on inside the model, and try out some stuff. Good. So let's quickly update the simulation so that we got the 3D model popping up. And then we can take a look on what it does. Remember, this is just a relatively simple plant model, so there's no controller included here, but for the sake of our versioning journey, that should do it.
Yeah, definitely.
Okay. I always like to flip this a little bit around.
Visualization, perfect.
Some visualization, exactly. And you can see what's going to happen here. So it's just that each of those stamps is lifted up one at a time.
Okay.
And that's basically the test case here. So just that you know, this contains some serious sim mechanics, but it's not really the purpose of our work today. Okay, so let's bring this in a project. And there's a tool inside Simulink, which is called Simulink Project. If you like using the mouse better, you can do so as well with the command new in Simulink Project, but let me fire up Simulink Project via the command line here. Okay, so you see there's no project loaded, but I can of course say I want a new blank project. And I give that project a name, double wishbone. But I don't want to leave it in a subfolder beneath or below the folder that we're currently in, but I want to just use the folder that we already have. So I say create. Geez, you see, it has no files.
Yeah.
It's an empty project. So what do? We go to all files in our current folder, and we need to add the files and folders.
Yep.
And so this is, by the way, a good point to ensure that you're not adding files to the project that are just intermediate artifacts or such.
Okay.
So you just want to have the real artifacts, and maybe the artifacts that take very long to regenerate if lost. But don't add everything to the project.
Well, this is the time for sorting your models.
Oh yes.
Sorting everything out that is not useful.
Oh yes. So what I will do first is I will add all those folders to the project, including child files, and I will also add those files here.
Yep.
See, it's done. If we now go to project files,
all are there.
We see it's all there. So, how to use now the Git source control? Well, in case you don't know, so I didn't know when I first used it.
Well, I would use the documentation.
Absolutely, that's always a fantastic idea to use the documentation. And in order to do that, let's make this smaller. And I'll just type .git and guess what comes up.
Hopefully at first position, yes. Set up Git source control.
Yeah. And to be honest, I've tried this out before. Good. So it walks you through the necessary steps to set it up. It also tells you installing the command line client, and you can also just install the command line client from this address.
Okay.
I used a different one, but this one should work as well. So we had that. Then what we need to do is we need to make Git aware that it should not try to dive too deeply into the Simulink model files, because it should consider those as binary.
Yep.
Because even while you can read an MDL file, it's ASCII text, you shouldn't alter it and shouldn't merge and diff it really, because there's no real meaning attached to it. So what it tells us, We shall add a file called git attributes, and let's do that. Added git attributes. Yes,
well,
please.
what we are doing here is called registering.
Yes.
And to say it simple, all files that may occur, well, will be converted so that Git can deal with them.
They're not converted. They're treated as binary files. Simply. So that's all. So let's save this file.
Okay. And there we see PDFs, JPEGs,
exactly.
Almost every data that we come across.
Exactly. So name it git attributes. And again, this is not yet part of our project, so we want to add that to the project. And now we can add this to source control.
Source control, yep.
So we select source control in our project window. We add this project to source control. And you see, we could also select SVN. So if you have Subversion running in your project, that's good as well. But we're going to select Git. This is the project root. Git creates a repository in the current folder, which you can then clone to so-called remote repositories. And so the synchronization runs that you have your local repository, and you synchronize that with a remote repository, and the other person that you're collaborating with, your teammate, also creates a clone of that remote repository. And you both synchronize with that, so you both have your repositories at hand. You can do versioning, diffing, without ever being connected to the network. And then you synchronize with the central repository.
So my workflow would be in a team, we have a certain network drive or internet drive where the model is stored. I grab it, work on it, and if it's fine, I push it back to this.
Exactly.
Exactly. Central location.
Which of course makes it very quick to commit changes to your local repository. So let the machine run and add all the files to the Git repository. Since this project also contains CAD files and
CAD files,
so it's kind of roughly 200 megabytes. So I would expect it to last a couple of seconds.
But this is typical for my student teams. They have a lot of data.
Well, I don't know. So, dear teams out there, what is the typical size of your software projects? I don't know. Let us know. Okay, that's it. So let's open the project. Now, the files are now added as to be added to source control. But now, if we look to modified files, and we should do so, you see in modified files it's all full. Why? Because we still need to do the commit. So all the files are now marked to be added to the Git repository, and what we now will do is we actually will add it. And as always, when using a versioning tool, I would highly encourage you to always enter a comment. What you did. So this is the initial commit. And I'll just submit it.
That means now they are put under version control.
Yes, they now live in the Git repository.
What I also see here is a folder called shortcuts. Can this be helpful for us?
Yes, absolutely. So we did run this startup MATLAB script, and ideally, whenever we open the project, it would be nice if that startup script would run automatically. So Simulink Project offers a possibility to do so. So we create a shortcut from that file, right-clicking, create shortcut, and add it to the section General. And you see here the status is this is now in project with shortcut. Now if we take a look to the shortcuts, you see you can create different sections, and for our simple case we just have a general section, but if you have a lot of different shortcuts, you may want to group them into two. So again, right click and say we want to set a shortcut action, because this MATLAB file should be run at startup, project startup time.
Okay, this is extremely helpful. A certain script that does certain tasks when opening the model, when closing the model.
Yeah,
that makes it easier.
So you may know the callback functions in a Simulink model that allow you to, let's say, set up the workspace and do all stuff like that. But if you have several Simulink files, you would have to add callbacks with checking that this callback not already has been run, and it's a little bit cumbersome to do this with multiple Simulink files. So now you have it on a project level.
Okay.
Making it clearer and keeping your Simulink model free of all those callback functions. Great. What we want to do now is we changed the project settings. So what we can do is we commit that to the Git repository. Added shortcut.
Okay.
And now you see I do commits to the Git repository very often. Whenever I change something, I commit. Because it's local, it's very quick. And the more commits you have to your repository, the better and fine-grained you can check what you did, how you did it, what changes you applied.
The more steps I have to get back to.
Yeah, exactly. Exactly.
Cool. I think now we are at the point where we can go to our model, do some changes, and see how the versioning behaves.
Yeah, let's do so. So, opening up the model and selecting, well, the right front suspension. And what I'm going to do is, all the mechanical engineers, please forgive me, I will just change some things and not really care about whether the model does something meaningful after that or not. So I open this cylindrical joint, I go to the internal mechanics parameters, and I will change the spring stiffness to, let's say, 3.
Well, for a suspension engineer, this would be horrible gambling. But
well, yes, my dear.
We are interested in changing something in the model, and
so please all you chassis developers out there, forgive me.
Yeah, no worries.
What else could we do? We could change a block, maybe. So throw out this spherical joint and add a different one. Still, of course, from the sim mechanics library. Here we go, Simscape library. We go to Sim Mechanics, the second generation joints, and we take, let's take the 6 degrees of freedom. Let's rotate it. Rotating is still Control R. That has not changed. We don't need the library anymore. What else could you do? You could beautify your model. And beautification, maybe doing a little bit of this or spreading out some blocks and changing here and there. And what else could we do?
If I actually change something at the wiring of the blocks?
Oh yeah, let's do that. Let's do that. Changing something at the wiring. So why not completely change the wiring here? So for example, disconnect those two and reconnect it in this way. Is that bad enough, or do we need to go
I guess so. I guess so.
And we can also maybe change the name of this block. SPA. That should do it.
Cool.
Are those the changes that you usually do?
I think we have done all changes I can imagine. Change blocks, change names, cosmetic change.
Could delete a block.
Yep.
We could delete a block. Let's delete a block. Why not? Why not delete that constant block and feed this constant? So I'm pretty sure that I completely functionally broke the model now, but I hope.
It's all about change.
It's all about change.
Let's have a look at the changes and how they are documented.
Yeah. So I save the model. I close it. Guess what I do?
Yeah. Go to modified files and commit them.
Commit them. Again, please document what you did. He broke model. Complete ly. completely. Yes. Submit this. Checking in files. Going back to project files. So now your colleague, who has the very same functionality, the very same repository, that he or she gets if you push it to the central server location. And this is why you have this push and fetch button here. So if I click now, so we can't perform any remote operation because there is no remote repository for this repository. If you go through the Git introductions, you will learn how to create remote repositories and how to synchronize with them and how to connect them. And if you have a remote repository, you can push it and fetch it. And so the other person on the team then needs to do a fetch to get the same changes into their repository. So this is why you have the push and fetch here. Let's actually check for the changes. So we want to compare to a revision. Right click, compare to a revision. You see, there's
we have two versions.
Two versions.
The initial commit and the completely breaking the model.
Exactly. And we want to compare it with the to the initial commit. Let's do so. So this does a model comparison on the basically on the model tree. This is what you will see in just a second, and highlighting all the changes that we did. Okay, here we go. So if we now have a look, we have all the changes in this hierarchy, and can review all those changes.
So what do we have? We have changed some wiring. Can we see that?
Absolutely, absolutely. So let's see what we did. So see what's happening
can
now?
be displayed.
Absolutely,
not just
absolutely,
text.
absolutely.
Okay.
So you see, it says this constant block vanished. It's no longer there. Then what did we do? We changed some wiring. See, we have a red line here. That is now not just a red line, but actually we have a changed wiring here again.
How can I make the model changes visible directly from the comparison tool?
Yeah, I just left click on any change that I see here.
Straight hit it.
And it's displayed here. Now, the change here is the parameter, which you can see down here. We changed it from 0 to 3. And actually to see this, it's marked in blue.
Okay, also highlighted.
Yeah, it's highlighted. It's highlighted in blue. See the blue color here. Now, what else did we change? We changed the wiring here. See. And by the way, if you still haven't used one of the more recent versions, you now can tell whether lines are crossing or connected.
Oh, okay, that's very important.
Same story here. Then we changed a
name, probably.
A name. We changed the name. That should be it. That should pretty much be it. Oh no, that was the block that we deleted.
Okay.
See?
Yeah, in the bottom model, there's no block. No,
Yeah.
Is there a block?
Yeah, there's the 60
the
degrees
new
of
block.
freedom. That's the new block. And with this way, you can pretty much step through all the changes that are in the model. And that's it.
Okay,
That's
cool.
it. Are you missing any changes?
No, I can't remember any change that is not documented.
Well, actually, we have some changes that we didn't step through.
Okay.
Which is, we did some cosmetics to the model. You remember?
Yes, you shifted some blocks.
I shifted some blocks, but this is not shown. Why? Because it didn't change any of the functionality.
Okay.
So we filtered this out.
Okay.
But if you want to see all the changes, you can go to the View menu and select a filter.
Okay.
And see, I did hide non-functional changes.
Okay.
I did not hide changes in lines. So if we unhide the non-functional changes,
well, there will be
you
quite
see,
some more
there
changes.
will be quite some more, absolutely. So all this stuff here, transform lower base.
Okay.
See that changed position. So if you want to get a sense about the cosmetic changes that were made,
we can do it like this.
You can enable it, but
yeah.
all of the time I have I hide the non-functional.
Well,
changes.
Joachim, now I have a question.
Yes.
We screwed the model up
Yes.
completely.
Yep.
So the task would be, how can I get back to the last functioning model?
Yes. So let's close this all down. You can do a right click, and you can say revert using Git.
Okay. And this is where Git is extremely helpful.
Oh yes.
Yep.
Yeah. And we want to revert to the previous version. So in this case, we only have 2 revisions of it, but for the sake of showing it, we can revert it. Be aware, if you say revert to that version, you will lose all the changes that you did since then. If you want to be a little bit more specific, you may want to up both models in the comparison tool and do the changes manually.
Okay.
Revert the changes manually. Okay, so guess what has happened now if we look to...
Well, there are some modified files and we have to commit them again.
Exactly,
right?
and if you take a look here, you even get a graphic indicator.
Okay, it's modified.
Whether the file has been changed or not. So we will find this file again in the modified things. Because the way Git does it, it does not go back to that revision, but it copies that revision.
Okay.
And you now need to add it as a new revision of that file. So if we commit it, revert it, changes to unbreak, checking in the files, and that should do it. If we now look to the project files, we can show the revisions.
Okay.
And you see we have the revert, we have the breaking, and we have the initial commit.
There's no sense in doing that, but I could go back to the broken model. If I
Absolutely,
want to.
yeah,
Okay.
absolutely.
Yeah.
Sure, absolutely. Good.
I think this was basically all of that. I hope, this was interesting for you. If you have any questions, I think there are several ways how to contact us.
Yeah.
I will show you in the last slide how you can contact us.
Yeah.
Before ending that session, Joachim, would be cool if you summarize the today's points.
Absolutely, I want to do so. But before doing that, remember that when we talked about what Git is all about, we talked about branching.
Yes.
We talked about branching.
Yes.
So we might want to spend a minute or two on that.
Definitely. Yep.
So we're now, it's just a few weeks until the competition season really begins. So most likely, if you do experiments in your software, in your models, you don't want to break your main development path. Because all your teammates will get mad at you if you try something out and by that break all that you've done. That's where branching comes handy, because you have a main development branch that you use to develop your stuff and make all the bug fixes and enhancements. Now if you want to do an experiment, try something out, try a different controller strategy that you're not sure it will work, you create a branch in Git.
Yes.
You branch off the main path and try it out. And only if it works, you put that changes back into the main branch. This is where the branching comes handy. So we could say, please create an experimental branch. Experimental controller. And create that branch. Switch to that branch. Do all what you want, add files, change files, without ever harming the main branch that all your teammates use.
Okay.
And even if you yourself want to go go back to the main branch after you've done some commits on this experimental branch,
well, I can put it to the main branch.
you can either put it to the main branch, or if you're not yet sure, you simply again go to this Manage Branches tool, select the master branch, say switch.
Okay.
And if you're pretty sure that you wanna merge the changes from the experimental branch,
Okay.
you can select experimental control and click merge here. Be aware, if you have a cumbersome model structure, that this will break. But I'm going to mention that in just a second. So, wrapping up, I'd say I highly encourage you really to use Git for versioning. If you're not using any version control, you need to be starting with Git. You absolutely need to. If you're not, it's not the question whether your project will break at any point in time. It's just the question when.
When? Yeah.
So you absolutely need to put all your artifacts under version control, not just MATLAB scripts and data files and Simulink models, but all of your code. And I personally even apply it to all of my documents as well.
But that's interesting to mention, Joachim. Git is not just available for MATLAB or Simulink. You can use it for any kind of data.
General purpose versioning system. I use it virtually for every document that I have. You could even be thinking about putting all your, let's say, I don't know, your PowerPoint presentations that you also need for the competitions. Put that in the same repository. Absolutely, you could do so.
Well, why not thinking about putting that to a larger scale and use versioning?
Absolutely. If you're using Subversion, that's great. Continue using it. Works as well with Simulink Project. If you have no urge to switch tools on that, don't. You need to be using Simulink Project, please. Absolutely do so. It's wrapping all of your models and MATLAB code and other artifacts into this project concept where the stuff knows where it belongs.
Okay.
And last but not least, please revisit the earlier episode on model structuring in Simulink.
Yeah, we had that.
Yeah, and could you put a link in the show notes?
I will put a link to the video so that you can directly revisit that.
Great. Because we're talking about really how to properly structure your model in Simulink. Also to enable you to work in parallel on different parts of the model without having to worry too much about branching and merging each and every time and simultaneous editing. If you have a good model structure, you pretty much can do joint and collaborative work without stepping on each other's foot.
I think model structuring comes first and then comes versioning.
Absolutely, absolutely. And even if you now say, okay, we want to restructure our models, please put them in version control first. Because if you break something, you can go back.
Yep, that's good.
Good. Having said that,
well, this brings us to the end of today's session. Thank you very much, Joachim.
Sure.
Very interesting. I think it's extremely helpful for you. Again, to wrap up, you all have access to our complimentary Formula Student software license. Just follow that link. In some cases, we had teams approaching us asking for new toolboxes. Well, that's not a problem. We can do that straightforward. If you use our software, we would be happy if you use our logo on your reports or in your presentations. And you can contact us with our team's email address, formulastudent@mathworks.com. And you will find additional resources on the webpage of the Racing Lounge and also in MATLAB Answers. So again, this concludes today's session. Thank you and hopefully see you next time.
goodbye.
Bye bye.